Hi, this is the first time I'm posting an update on YouTube, so I wish I'll do good this time. On this video, I'm introducing my new project. This is a device that takes data from my car through the OBD port, the diagnostics port, and it will send the data through Wi-Fi. So to achieve that, I designed this device. As you can see, it's made of cheap components, either from mostly AliExpress or some used wiring. Well, basically it's cheap to do, and I will make it open source, as I like to do, to share with you a possibility to explore your vehicles. So as you can see, the case is rather, well, it's not too big, not too small. Well, so to design this, I have used 2 microcontrollers, which are ESP32 microcontrollers by Espressif. They are very cheap. They use FreeRTOS and LwIP, lightweight IP, that means. And you can do Wi-Fi with them, and I will make an HTTP server with the WebSocket on it, like I do on the current software I already have made on Python. But it will be directly embedded within my device. About the structure of my device, I have 2 microcontroller boards connected to 1 voltage regulator for each, and for each microcontroller there is a CAN transceiver, a CAN bus transceiver that is meant to send data to the microcontroller and to allow the microcontroller to drive the CAN bus, meaning that it writes onto the CAN bus. So I will make it as fully featured as I can. Basically, these microcontrollers are powerful. I mean, they can work at 240 megahertz, which is a lot for a microcontroller. And for me, it's really nice because it will open possibilities for experiments. And in my case, I have an extra display on my tablet, plus I record, as you could see on my previous videos. You have counters everywhere, so in place of my OBD scanners, I will just use a single device. That's the plan, and this device will filter CAN bus packets that are repeated way too often, and data will be decoded directly within the device instead of running a Python program on the computer, which will free some CPU power on the computer. and the latency will be reduced when it comes to uh, the boost gauge, the accelerator, and the brake gauges, because the way I did it was well, there are too much data to handle, so I faked getting those data like they were OBD requests, but they are just monitoring the CAN bus for a short while. But they are treated in my program like they are OBD requests, and that adds some latency. While the data would just be available right when they are broadcast on the CAN bus. Well, that's it for this new project. I hope you like it, and when it's finished, well, when I have the first version, the first working version, I will of course post a video to demonstrate how better it is. Um, I mean, for lower latencies. So, thank you for watching and see you later on board. Haha.